Hello there, this is Phil Sluder, Triaxial Design and Analysis, still alive and well and doing business in San Diego. So I'm staring out the window right now at my camper and I'm ready to get out of here. So yeah, I'm a little anxious. So let's get going with some tips, huh? Okay, so my favorite interview question when I'm interviewing people is tell me the difference between a configuration and a display state. And it's really a little bit simpler than this diagram I've got up on the screen. So I wanted to quickly go over a super simple example of the differences. Okay? So basically part configurations are versions of the part, and we're only going to talk about part configurations, not assembly configurations and assembly display states, because that gets way more complex. So this is the first hurdle to cross. Part configurations are versions of a part that you can specify two things: the value of a dimension and whether a feature is suppressed or unsuppressed. And it could be a combination of those. In this example, we've got three different size discs, the blue, the green, and the red, and they all three have different values for the diameter. So that's the value of a dimension. So that's one thing we're going to vary. And the second thing we're going to vary is whether a feature is suppressed or unsuppressed. So in the blue one, you can see it's got a circle for a feature. It's a cut with a circle in the sketch. And then in the green one, a completely different feature is a square and a sketch and a cut through the green disc. And then in the red one, there's a third feature that is a hex-shaped sketch and a hex-shaped cut. So there's actually going to be multiple features there's a combination of suppressing and unsuppressing. And we're not going to get into design tables. We're not going to talk about the hard way to do this. We're going to talk about the easy way to do this. Okay, so let's go ahead and open up a new part. And let's just make it in inches. And I'm starting with a template of a cylinder. And we said we want to vary the value of the dimension, and it's going to be both 3, 4, and 5 are going to be the, oops, wrong one. Wrong one again. Here we go. So we've got 3, 4, and 5. This table kind of summarizes it. 3, 4, and 5 are the diameters, and then round, hex, round, square, and hex. Okay, so let's go back to SolidWorks. So we double click on this, and here is the value we want to change. So all we have to do to make three different configurations is we could either right click on this and say configure dimension, and we could actually add a new configuration right here. Just click here and add the name of the configuration. But let's do it a little bit simpler. Let's go to the configuration property manager. Okay, so now let's add some more configuration. Let's add a round, and we'll add another configuration called square. And we're going to add another configuration called hex. Okay. So, and now we really don't need the default anymore, so I'm going to delete that. You have to have a configuration, but you don't have to keep the default, right? Now, if you notice, since the display states are linked to the configuration, hex is going to be display state 4, square is going to be display state 3, and round is going to be display state 2. So each configuration has its own display state. In other words, the display state is linked to a specific configuration. Okay, now let's go back and change the value of that dimension. So now if we do the same thing, we're not going to do design tables or anything like that. We're just going to say right click and configure dimension. And we're looking at this table now, and we can see the configurations are in there, and we're just going to change the value. Now these boxes are less than ideal, the feedback, and it may just be on my graphics card, but see how it looks like it's not going to do anything, but it's going to be fine. So I'm just going to type in 4 there, and then I'm going to type in 5 there. So I've changed the values of that dimension in those 3 configs, and we just say OK. And now magically, when we change to the other configuration, it changes the diameter of the disk or the value of that dimension. So it's as easy as that. Okay? So if we look back at the tree, we've still got the same first feature, but we've got 3 different values for that diameter. Now let's add those other features that we're talking about that we're going to suppress and unsuppress. So I'm going to open up a sketch here, draw a circle, and then I'll just blast that through. It's a cut through all. Say OK. OK, there's one feature. Now let's go to another config. Let's see, how would we do this to make it interesting? So let's just put another one right on top of it. No, actually, let's roll it back. And then I'll put another sketch here. I'll just put the square. Pretend that's a square. And I'm going to blast that through all. Okay, and I'll roll it back again. This is just so you can see me creating the individual features. Do another sketch. This time I'll use a hex. Blast that through. So now we're going to have 3 different features, and they're all on at the same time right now, but we're going to take care of that. So let's go back and Control select the features we want to configure. Just like configure dimension, we picked a dimension. Now we're going to right click and do configure feature. Okay, and now if we look at this table, you can see what's going on, and I can spread these out so you can read it a little bit better. The first one we did is cut extrude 1, so that was the round one, right? So I want it suppressed in the 2 configurations except the round. The second one I did was the square, so we actually want it suppressed in the round and suppressed in the hex, not suppressed in the square configuration. And then the same thing for the hex. I want it unsuppressed or this unchecked in the hex config and then suppressed in the other 2. So all we're doing is arranging the checkboxes like we want them. That's all we had to do. Say OK. And now if we go back to our configuration tab, we've got round, square, and hex. And notice the values of those dimensions are still there. So we've pretty much filled out our table here. We've got the 3, 4, 5, and then we've got the round, square, hex. But you're thinking, well, how come the colors didn't change? Or to be more precise, the appearances didn't change. Okay, so well, we got to deal with that. That's not done in the configuration. That's done in the display states. So let's go back. And there's a couple of gotchas on this. So display states are versions of the appearance of a part. So in other words, we can have one appearance is blue, one appearance is green, one appearance is red, etc., and then these display states, there's a tricky setting. You have to say either this display state or all display states, and by default, again, it's going to default to all display states, so you kind of have to pay attention to that. So let's go back to SOLIDWORKS. Okay, the easiest way I know of to change an appearance is just go to the Feature Manager design tree, and I guess I should note, remember display state 2 is tied to the round, display state 3 is tied to the square, and display state 4 is tied to the hex. So that's happening automatically. So whatever we make changes to the appearance here, technically will affect just this one, but that's where that setting comes in. So I'm going to go back to the Feature Manager design tree. I'm going to right click on here. I'm going to go up to the Appearance button right here. I'm going to pull it down and pick Part. And the first one was supposed to be blue, I believe, so we're really not changing anything, but let's just change it to a blue just for the heck of it. And then down below, make sure it says this display state and not all display states, okay? Now let's go back and change it to the square, and let's go to that same place again, except now we're in another display state, so therefore it's going to affect a different display state. And this one was supposed to be green, so let's pick a green and make sure it says this display state down at the bottom. And then let's do the same thing for the hex. And this one, go back here, and this one's going to be, of course, red. Make it a nice bold red. Okay, so now when we change to configs, we've got all three of them appearing like we want. So we use display states to keep track of the appearance or the color. Okay, now what does this look like? I gotta save this before SOLIDWORKS crashes. No, I mean before I put it into assembly. And let's see. And it's going to remind me I have to save it. So let's just call it part 1. And I want to bring this into an assembly. Again, I'm using a template. And I'm just going to put that one there, and it came in under that configuration and that display state because that's what was active. And I'm just control dragging and making some copies. So now when I go to the properties, I can change it right here, or I could go, you could go to the properties the old school way, and you could do it here. Okay, so let's do it the cool way. And the only thing wrong with this cool way is you got to remember to hit that check or it won't stick. And then let's change this to square. Check. Okay, so we've got all three of them in the same assembly. There are 3 instances of the part, 3 different display states, 3 different configs. Okay, now what was that link thing we were talking about? Let's go ahead and unlink them. So if we go to any of the display states, it doesn't matter which one, and you uncheck link, now look what we got. We've got 2, 3, and 4 are available in the hex. So we can change the hex to be green or to be blue. And it's the same thing with the round. If we go to the round, we could change the display state. So it's like any combination is possible, any configuration and any display state. But of course that is a slightly more complicated, and it's going to get even more complicated in here. So we could go to those properties again. We can't pick it from up here anymore. We want to go to the properties, component properties, and we can pick square, and we can pick display state 4. Okay, so now we've got a red square one. And if we go to this one, we could say go to the properties again, and we could say give me a round one in this position, in this instant. And then let's see, let's pick 2. So this should be round and blue, and then on and on. And I really think those shadows are annoying. So anyway, there's configurations display state in just a few minutes, 15 minutes. Okay, we got another half hour. All right, so there we go. Hope that's a good review for you. Or if you're learning it for the first time, it'll be on the interview question. If you ever want to work for Traxial, I'm gonna ask you that question, so don't fumble it. All right, so now let's go back to our PowerPoint. All right, let's walk through the actual construction of the spring. Okay, so this is an in-context assembly that I've created, and its only purpose in life is to create the in-context relationships that are going to apply to this particular spring. And when we put it in the next assembly where this spring is actually going to be used in multiple instances, and each one is going to have a different shape, it's going to use the in-context relationships we create here to apply it and make it flexible. And it'll make sense more when we look at the next assembly. But let's just work on making this spring in context. And this is the same stuff you've been able to do since probably 95 SolidWorks. It's just an in-context spring. So if we move one of the components in our assembly and we rebuild, the spring will update. And when we bring it back down, notice it doesn't do anything, and we rebuild and it updates. Now we can put this spring in an assembly now, but it's always going to take the shape of whatever the active part is doing. In other words, whatever this part does, that's what it's going to look like in the assembly. Okay, so we need to make this in context spring first. So let's just walk through that. I'm going to edit this part so we can walk through the tree. And I'm going to start with the plane. And this plane, I've just built it off of the top plane of the spring. I'm going to keep referring to the spring. So the spring, the first feature on the spring is an offset plane of 2 inches from the top plane of that same spring. And then I created a sketch, and the sketch plane of this sketch is the top plane of the same spring. So we're not relating to any of the other parts in the assembly right now. And then to get that sketch, I just converted an edge, and the edge I converted happened to be the top edge of this disc on the top that's going to go up and down, right? So that's our first relationship between the spring and this outside part in this assembly. It's another part in the assembly, so that's why we get the little in context arrowhead there, right? So that's our first relationship. And then the second one is this sketch, or the sweep. This is this I guess the third feature. So how we did that is first let's see, what do I want to show you first? Yeah, let's talk about the profile first. So we went to the profile, and it's just a circle in that same, it's on the front plane, I believe, and we made a pierce between the center of the circle and that sketch we just created, we just converted. Okay, so it's relating the circle to another sketch in the same spring. So we didn't go to the edge of this disc, we went to the sketch we created. Okay, so that's the profile. And then for the path, I just drew a straight line in the same spring part from the origin of the spring part up, and this happens to be coincident with that plane. So that dictates the length of the spring. So it's between the origin and that plane we added as the very first feature in the spring. Okay. And then to get the sweep itself, you're saying, how did you get it to do a helix like that? Well, if you use those same 2 sketches for the path and the profile, and then for the profile twist, you don't say none, its default is none, but you change it to specify twist value. And I said I'm going to control the twist by the number of revolutions, and then the direction 1 is just the value of how many revolutions. So we want 2, so it makes 2 complete revolutions, and you end up with something that looks just like a coil spring. It's a helix. So that sweep is going the circle, twisting it around the path, which is just a straight line, and you end up with a spring. Now this is the part of the spring that isn't going to compress or extend. And then I added a couple more features. I added a plane, and that plane happens to be on the face of that disc up there. So that's the second thing that's in context in this assembly. and that'll be important later. There'll be a quiz on it. Okay, so we've got both that conversion of the edge and then that face. Okay, and if you remember, the thing I converted was this edge up here. So we've got both things coming off of this upper disc that moves. Okay, so that we made a plane there, and then I added another plane. I took that same plane and I used that as an offset for this plane. And then the next thing I did was I created a sketch on this plane, and I converted the edge. The edge I converted was not the edge of the disc, it was actually that sketch we did at the very beginning. Okay, so that projects that up to this sketch plane. So still we're not relating to any other components because this lower sketch was in our spring, and I converted that to this plane and this sketch. Okay, and then I actually drew this line in between the two planes on another sketch, and it's not related outside the spring either. And then I did that same trick with the circle, and I pierced that sketch I just talked about that we converted, and it's the same setup. I guess we can edit that and show it to you real quick. So we got the circle, and it's piercing, or that pierce point is this circular sketch here. Okay, and so now we've got everything we need to do to make that second sweep. And that second sweep was done just the way the first sweep was. 2 revolutions and ended it right there. Now for this third one, I'm rolling it back funny so you can see the order it was created in. I created a third straight line which just connects one straight line with the other one. Those 2 sketches at the top and the bottom that we used for the paths of the 2 sweeps, I added one more line between them. Okay, and then for the profile of the sweep, I just opened a sketch on the flat end of that first coil of spring, and I converted that edge, and that is in exactly the right spot to do our last sweep. Okay, but that last sweep depends on this path, or this path, and as that disc here moves up and down in our assembly, that path that we're talking about right now is going to get longer or shorter as this goes up and down. So that's going to make our number of coils stay the same, but the length of that line will be longer, so it'll appear that this spring is extending. Okay, and then just to make things nice and neat, I cut off the top and bottom, so it looks more like a real spring that's been ground down on the ends. So that's what we end up with, and that's why when I move this up a little bit, and it doesn't rebuild automatically, you have to hit rebuild, and see now it changed the distance that center or middle sweep twists along, and I can bring it back down and it'll compress, but I have to hit rebuild. But it doesn't change the number of coils, so it looks like it's just a spring going up and extending and compressing. All right, now I'm going to take a look at the assembly, and that's the wrong PowerPoint again, this one. We're going to take a look at this assembly, and what we've got here is I've got that same spring we just looked at, and I've got it mated in 3 different positions in this top assembly. So this would be your assembly you're actually working with. It could be a suspension, or it could be some kind of a hose connections or whatever, but this is where you want the different geometries in this assembly. That other assembly we're just looking at is just for construction. Okay, so now we've got the 3 springs and they're all mated, but notice they're all the same because we haven't turned them into a flexible component yet. To turn them into a flexible component, you just right click on the part, and you can do this either in the feature tree or just in the graphics area. And we're looking for this symbol right here. It says make part flexible, that icon. So I'm going to pick that, and notice there's 2 different things it's asking for. It's looking for a reference entity or a sketch or an edge, something to relate the top of the spring to. And I'm just going to pick this edge right here. And then it's also looking for a face that the end of the spring is going to end up at, and I'm going to pick this face. And it doesn't say you're good, it just doesn't say you're bad, it just green checks, and now you're ready to just say okay, and this spring extends to meet that particular upper disc. Okay, but notice the other ones aren't moving. They're still at their original position. They are in that in context assembly that we used for construction. So to get these to flex, you do these as well. So this particular one, we're going to use this edge and this face. Say OK. And we'll repeat the same thing here. Right click, or just click, and then make part flexible, edge, and a face. Now if you end up with a bunch of different relationships here, if you're trying to duplicate this and you just do 2, you're good. But if you end up with 4 or 5, that means you added too many in-context relationships in the assembly. It could be a sketch plane, it could be converting an edge, it could be all different kinds of ways you added those in-context relationships in the construction assembly, but you only need 2, and 2 is going to be ideal because then you only have to add 2 every time you add an instance of the spring. So anyway, now you can see we've got 3 different ones with 3 different lengths, or 3 different geometries, I should say, but it's the same part. It's just 3 different instances of the same part, and they all have different geometry depending on what the other things in the assembly are doing. Okay, and see, you don't need to rebuild, and plus you get, here's our item number, it's spring, and it's called flexible component as a description, and we've got quantity of 3, even though all 3 of them are different geometries. Okay, so that's the beauty of a flexible component. All right? Okay, and now just for entertainment value, I'm going to show you a very special project. So here's, I got to explain what a sweep dog is. If anybody remembers back in the day, I did some presentations where we included the sweep dog because we were talking about sweeps. And the sweep dog was actually in Alice in Wonderland, and it would go down the path sweeping it away so Alice in Wonderland would be lost. And that's a picture of the sweep dog, a very rare picture of a sweep dog. Okay, now these are spring dogs, and these are based on what we just saw. So the idea is we have 2 springs, flex spring here and flex spring here. It's the same part, but it's flexed in 2 different positions. And then all we do, and you have to be a little careful, but see how it instantly changes it as soon as you stop moving the part that's free to move? And this is happening in, you know, all 3 dimensions. So this is done differently than the one I just created. But you can see see how flexible it is. So that's in a little bit more complex example. You just had to make this in context, and then you basically created relationships just like we did on the previous one, except the previous one was a little simpler. All right? So now let's move on. Next thing I'm going to show you is some actual engineering, because you guys have been seeing me do all this silly stuff with SOLIDWORKS for 20 plus years now, and you probably doubted that I was an actual mechanical engineer. So let's talk about it. So one of the things I'm very familiar with is how to make molded pulp. So let's say this is a product and this is the pulp that I designed to go around it. And now it's very simplified, there's no fillets or anything, but that's not really needed for this discussion. So quickly I want to show you how I created it. So let's say we edit this part, and let's roll it back. So first I have a part turned off. So this is a part that represents the size of the box, right? And then from that, I'll turn that off now. From that I created the pulp. We call these end caps because it goes around the end. So first I made the basic shape, then I cut out for the actual part with just a little bit of clearance, and then I did these cutouts for a rib. So if we look at this, let me hide this guy so it doesn't get in the way. So I cut out one rib, and there's lots of different things, like this has to be a certain width at the bottom and the draft angle and everything. And then we did a pattern of those ribs. So there's a pattern in that direction. And then I did a rib in the other direction. Okay, it's not shelled out or anything yet. And you could use this for pulp, you could use this for any kind of clamshell things, even the plastic will work too. It's the technique. And I know there's a lot of different ways to do it, but I've been doing this for like 24 years, and this is the easiest way I've found to do it, is just do it from one side and then shell it out later. And then we put chamfers on the corners, because on pulp the corners like to warp. And then I put draft on the outside, and then I shelled it from the back side. Okay. And of course, if you were adding fillets, you'd put the fillets on before you shelled it. And then I move the face on the bottom so we get what we call a skirt. And then that's our finished part. Now, the actual engineering part is what happens when this thing, imagine this thing is put into a box, just like it is, and the box is surrounding it on all 6 sides. And what if the box drops or slams against a wall or something in, let's say, this direction? Well, how do you figure out how many ribs you need to protect the part? And when I say protect the part, you want to keep the G-forces down. So this pulp is actually going to be somewhat springy. So just like if it was foam or something like that, it's going to have some spring to it. And so when it slams against the wall, let's say you dropped it straight on the concrete, 36 inches onto concrete, and the part is trying to crush the pulp, and the pulp is compressing, and you need to know how many ribs to put around this thing to make sure it doesn't overcompress or undercompress. So that's done by something called linear inches. And it's kind of like stress calculations, but this is very simplified because it's kind of a black magic, because there's not a lot of data on how pulp acts when you crush it, and you don't want to buy $100,000 worth of software to get real-time pulp crushing, and it probably wouldn't be super accurate anyway. So I'm going to go back to SolidWorks and show you one more thing. So let's see. Oops, I should have rolled that forward. Hang on. Okay, so now we've got this guy. Let's see, that's the wrong one. This guy, show it. Okay, so there it is, ready to go into the box. But if we drop it against that one side, it's going to look more like this. So the surfaces, or I should say walls, because it has a wall thickness, so that wall thickness is shown in pink. If it falls, let's say, straight down like that, these pink walls are the walls that are going to take all the loading. Let me go back and forth real quick. So there's what it was when it wasn't transparent, and then these are the walls that are going to take all the loading. So instead of figuring out square inches and stress, we're just going to use what these are always 1/8 of an inch thick in my world, and so we've come up with a number called linear inches. And so what we do in SolidWorks, we're going to add up the linear inches of all these different walls, and so the linear inch times the thickness is going to give us the square inches that's going to be compressed due to the load, and that's what'll sort of relate to stress, right? And that's what's going to cause it to compress. So if we go back to our PowerPoint, if we look like in this down direction, I've highlighted all the different, well, let's look at the one that we were just looking at. So here it is here. So this is the one, all I have to do is get the linear inches of this. So I just highlight all of them, all those edges, and I get the report from Measure, and it gives us the total length. And then we know what the product weighs. In this case, it's 4 pounds. And since there's 2 end caps, it's going to be the weight of the product divided by 2 on each piece of pulp. And so then you multiply that, or you divide the number of linear inches, and that gives us this 0.16 pounds per inch. Okay, now that's just a number, and then we look at a cushion curve that I helped develop, and this is how it's going to act. So, oops, that little arrow's in the wrong spot. So 0.16 is going to be right around here on the bottom scale. And so if we come up to our 1.5 inches long, see there's 3 different rib heights. This model, I didn't mention it, but it's drawn 1.5. So 1.5 is going to be this lowest curve. And so if we put a line straight up from 0.16, because that's what our value is here, this is going to give us about 60 Gs, where I wrote 55 Gs here. Okay, so that's on that edge. And then if we go to the bottom, it's just the full weight of the product, so it's going to end up about 0.26, and that's actually ideal. So that'll give us about 50 Gs, so that's a perfect amount of ribs. And then if we go to the other side, which is the ends, and they're always a little bit harder because there's not enough room to put ribs, we're going to end up with about 75 Gs. So that's a good compromise. So we're going from 55 Gs down through 50 Gs and then up to 75 Gs. So that's super, super approximate, but that's the easiest way to design the pulp. If you're doing it for some other pulp thickness, or you're doing it for some other pulp composition with more newspaper, less corrugated or whatever, it's going to be different. But this cushion curve is made just for this kind of pulp, and of course that was done with experimentation. Okay, so that's actual engineering at work in a SolidWorks tips and tricks session. Granted, it's very simple engineering, but it's actual engineering, right? Let's open up a brand new assembly, and we're going to use a template, right? So new template, and I'm going to use an inch template. So we're already using templates. Templates are great. And then I'm going to insert a new part, or I should say start a new part. New. Now we go to parts, and now I'm going to pick a template that I use all the time. It's rectangle with threaded holes. Okay, so all I have to do is adjust it for what I want, right? So I want this to be 100 by 75. Okay, so that's a good number. And then I want the hole pattern to be 18, and this one to be 35, and rebuild. And then I want this guy to be, instead of M3, I'm just going to go in and edit it, because that was part of our template, right? It had a threaded hole. And I'm going to change that to M5 and say OK. Okay, so there's one part. Now I'm going to create another part in our assembly. You probably don't remember what it was, but I'm going to create another part. And I'm going to use another template here called, and it's not there. Oh, there it is, lug. I knew it was there. I knew that. Okay, so now this one, I want to change this bolt pattern to be exactly what it was before. So this was going to be 35, and this one was going to be 18. Let's rebuild just so we can keep track of what we're doing. This lug here, it's a little too tall, so I'm going to change that. That is actually going to be 15 high, and then this radius is going to be 12. Rebuild that. And then we don't need that plate quite so wide. Let's do 35, oops, 35 by 50. That should be sufficient. Rebuild that. Okay, now let's do the tile horizontally, famous, and let's drag in our plate, and it's not going to let me because I didn't name it yet. So let's call this plate 1. And we'll save this one and call it lug 1. And let's drag that into our assembly also. I'm just going to use the famous, see if this works. The famous profile mate. It should work. Fairly simple. Everything lines up. All right, so there's our assembly, our mighty assembly. Okay, so there's just a couple more things I want to show you. And I noticed I started all this with templates. So if you've got that luxury, it's worth setting them up. Okay, now let's bring in some McMaster-Carr parts. So let's bring up we'll search McMaster-Carr. And we want 2 components in this for McMaster-Carr. So they are, of course you'd have to search and all that to do this properly, but I've already done the work. 6071 K65. And I'm just going to download that. Drag this right into our assembly. So there's the clevis, and then I want another part from McMaster-Carr, so I'm going to search for that. And it's 91292 A126. This should be our screw. Download. Drag it right into our assembly. Okay, here's a tip. So see all the sketches? They're all very annoying because they like to turn on all their sketches at McMaster-Carr, but I've got a solution for that, and I can share this with you guys. I just I'm not ready to talk about it too much at this moment in time. But there's all the stuff that's turned on, right? So if we go to macros, tools, macros, I've got a macro to solve this problem, and it's right here. And it pulls up a dialog box like this, and it turns everything off. And then when you go back into your assembly, I think it's going to be that one. Yeah, see, now everything's turned off like it should be. And let's see, then I'm just going to use some smart mates here to get that there. And then I'm going to take that part, and I'm going to go to our assemblies, and I'm going to pick a pattern-driven pattern, because these holes were done with toolbox, or the hole wizard I should say. Driving feature is that guy. Change the seed to this position, and now we've got 4 of those. Just got to mate this guy up. He goes through that hole obviously. And then here's something I want to make sure you know how to do too. So I want to do a width mate between the lug and the clevis. If I just pick the surfaces ahead of time, and I'm just control selecting the surfaces, look what pops up. Width mate knows that's what we're up to, and it just automatically goes there. So you don't have to worry about which surface goes to the tab and which one goes to the slot kind of thing. You can just do that. Okay, so normally you'd be done with this, but this is the other thing I wanted to show you. look over at the task pane. There's this funny McMaster-Carr symbol over there. So it's a mystery to me because some people know where it is and have it, and some people don't. But if you search for it, I wasn't able to find it. But I got it a long time ago because I helped them develop it. And I know they came out with it, but what it does is you pick that, and it tells you what parts of McMaster-Carr are in your assembly. And then you can preview the order. Here's the prices and all that, and this is the cool part. So there's 4 screws used in this, right? But we all know the screws come in boxes of 100. So it says 4 screws, but 1 pack of 100 is what it's added to the order. And then if we open the order, it takes us right to McMaster-Carr and shows you the order. And if you're logged in and have a direct, I could place the order just with one more click of the button, and it's on the way. It'll be here tomorrow. Tomorrow in 6 weeks. Did I pick something that was Oh wow, look, I picked something that was really rare. That's odd. So you'd have to go back and change that. But anyway, the other thing that this does for you is it actually, if you pick this hyperlink right here for the clevis, it takes you right to the entry on the McMaster-Carr catalog that is that. Okay, so I know I went way over time. I'm done, but let's see, there was nothing else, I don't believe. Oh, here I was just showing you, here's the McMaster-Carr part of it. So we went first to the add-in, and then to the cost, and then to the order. And that was it. So now I'm done. There's my email address if you need anything from me, and good talking to you guys again. It's been a while. So take care, and I'm again staring at my camper out in the driveway, so I will be out of here shortly. Bye.